A 3D printed house can, if well designed, cost 30 to 50% less than a stick-built house. If we maintain our profit margins at the industry standard, we can still make good money and sell houses hundreds of thousands of dollars less than conventional stick builders. This is good for society all around.
Welcome to the Construction Disruption Podcast, where we uncover the future of building and remodeling. Join us as we explore an industry that is evolving with new products, designs, practices, and technologies. From builders to remodelers to executives, as well as those with outside perspectives, each episode of Construction Disruption meets with forward thinkers, as well as others in the know who share their unique insights. Construction Disruption is created and sponsored by Isaiah Industries, a manufacturer of specialty metal roofing systems and other building materials. I'm Seth Heckerman, sales manager here at Isaiah. Todd Miller, our president, is our co-host today, and we're blessed to have Ryan Bell, our creative director, and Ethan Young, our content writer, helping behind the scenes. So Todd, really looking forward to today's conversation. First, though, I know we're recording this in kind of mid-November. We're starting that fourth quarter process of having talks internally about what 2021 is going to look like, having lots of conversations with our vendors and others in the industry. Would love to get some feedback on what you're hearing, what you think the next year is going to look like, and some things that are top of mind for you.
Well, good question. At my age, I'm just glad when there is another year, and I'm grateful for the fact that you're assuming that I will have another year. So
of course,
that's
absolutely.
Awesome. It's been such a weird year this year with the supply chain problems from a manufacturing standpoint. I had been saying most of the summer that what I was thinking and what I was hearing was that 2022 would be different in terms of being better as far as the supply chain delays and price increases. About a month ago, I quit saying that because I was pretty sure I was going to end up with egg on my face. And at this point, it truly does look like 2022 is going to be another tough year from a supply chain standpoint, which also means pricing as well. One of the things that we're seeing as a manufacturer, it seems like a lot of 2021 we dealt with issues getting our main commodities, metals, and now we're seeing it even to the point of where it's individual chemicals in coatings that are causing problems. And is there certain things you just can't substitute? You can't do anything else about them. So I think it's going to be another tough year. Good thing is, it still seems like the market and consumers out there are robust and interested in doing things to build buildings and improve upon existing buildings. So there's good signs. I don't want to say that all is doom and gloom. But I do think it's going to be another tough year from a supply standpoint, and my guess is it'll be late 2022, even into 2023, before we start to see maybe what a lot of us, old-timers at least, see as more normal patterns and situations out there at the supply chain.
Well, that's helpful perspective. Thank you, because though it's not the news we want to hear, you're in those circles and having those conversations that not many of us are privy to. So definitely helpful, and makes these conversations we're trying to have here with Construction Disruption and beyond all the more critical of, okay, what do we then do with that information and knowledge of what it's going to look like? How do we view things differently? How are we thinking along that timeline and even beyond to position ourselves better moving forward? So all the more motivation to continue looking ahead, innovating, and disrupting ourselves rather than letting ourselves be disrupted.
Yeah. There's always opportunities out there, and everything goes through cycles. You've always got ups and downs and roller coaster of life and roller coaster of business. But at the end of the day, there's always opportunities for those who are innovative, those who are looking and seeing things that can be made better. And I think that's a lot of what our conversations here on construction disruption are a lot about, is what is that better future of building and remodeling going to look like?
Absolutely. And I think our conversation today is going to dovetail really well with that. I'm very excited. Today on Construction Disruption, our guest is Ed Macnab, CEO of 3D Printed Homes Corporation, a startup in Alberta, Canada, looking to solve the challenge of housing affordability by advancing 3D printed construction. So Ed, thank you so much for joining us here today.
Happy to be here. Always happy to stand on a soapbox and sing the praises of this technology.
Well, we're looking forward to learning more from you and giving you that opportunity today. I'm looking forward to it because I'll be the first to admit I really know nothing about this technology. So it's going to be very enlightening for me and very much contribute to this grander conversation, bigger conversation about what the industry is going to look like moving forward. So to begin, I would love for you to start with, a little bit of your story about how you got here, invested in devoting your career to this technology. Looking at your LinkedIn profile and doing some research on the front end, it wasn't readily apparent about how there was a natural trajectory and path to where you are today. So would love to get some of that background history and understanding of what passions led you to 3D home construction.
Well, first off, you need to know that the construction 3D printing industry is so new that there is no sensible path to get there, to get to it. It has to happen by accident, pretty much. I grew up in Alberta, Canada, and to use a frame of reference, you guys might know it's Texas North. So I started out my working career in the oil field, and that's a great place to learn how things work, why things go round and round and up and down, and the interaction between them. Progressed through electronics, construction, a little bit of corporate finance and venture capital, and I finished my conventional working career as an international project manager for IT support projects. So working for a US-based company. Most of my work was done from home. But how did I end up here is kind of a funny story because it lines up really well with a comedy bit that we've all seen so many times. Frank, who is now our lead designer, had been involved in the hobbyist 3D printing space for a couple of years. And because of that, he started seeing articles on social media about companies in Europe that were investigating using the technology to build houses. That's pretty weird because the hobbyist machine is the size of a photocopier or smaller, and here they are building houses. So he was sitting in a coffee shop with a lady friend, and he mentioned this construction 3D printing. And they sketched out some house designs on paper napkins. And Frank said to his friend, I'd really like to do this, but I don't know anything about building houses. His friend, in classic comedy form, puts a finger in the air and says, I may know a guy. So Frank gets introduced to David, who is now our construction and materials guy. They both agree that there's merit to Frank's idea, but admit that they really don't know how to start a real survivable company. David does the finger in the air and says, I may know a guy. That guy was me. And David and I actually went to elementary school, grade 1, 60 years ago, and have had sort of a thready acquaintance over the intervening years. So that's the foundation of 3D PHC. I had enough business savvy and business learning from a long career to take the reins as CEO. We've since added a couple of key directors with other skills, but that is truly how we got started. Paper napkins and a coffee shop. Tim Hortons, for those who know.
Okay, there you go. The quintessential Canadian coffee shop.
Absolutely.
I prefer my coffee as a double-double when I'm in Ontario. You can't order it that way down here, though.
They don't know what you mean?
Right, no. Even Tim Hortons doesn't know. So, No, that sounds like fantastic trio there, and complementary skills coming to the table. It's interesting you starting to tell that story about the hobbyist 3D printing realm. That's what I've always, still didn't know very much about at all, but it was just this, magic box on top of a desk that, spit out a little trinket of sorts, or maybe a functional part that can be supplemented. So hearing 3D printing then in the context of home construction, blew my mind even more. So if you could, for those of us who don't know very much, give a 30,000 foot level of this technology and, how the technology in both applications, but then also, some greater details on how we then take that to then building houses would be helpful.
Sure. So first off, every adult who has kids has had their kid come home from an early grade school with a coffee cup that they made in class. And to make that coffee cup, they rolled clay out into a long rope, coiled it all up until it was in a coffee cup shape, and then maybe baked it in an oven and maybe not. And the end result is a stack that looks a bit like a stack of rope, but it's with luck, it'll hold water, and with real luck, it'll go through the dishwasher. So the hobbyist 3D printing uses a very similar process with plastic filament. So there's a big roll of plastic filament. It's fed through a hose to a nozzle that's hot, and the X and Y, like a plotter, the X and Y axis move this head around in the pattern that you want, and then it jumps up, say 0.5 millimeter, and it prints over top of them, and it sticks to the previous layer, and it jumps up, and it jumps up, and it jumps up, and eventually you get your coffee cup, or your key fob, or your baby Mandalorian, or even they're using it now to make, as you noted, functional parts, nylon gears and things like that. Well, if you take that machine and you make it bigger and then bigger and then bigger again until it's big enough to surround a house, and instead of putting plastic through it to be melted, you pump quick dry or controlled parameter concrete, and this nozzle runs around and it traces out the profile of the house. It jumps up an inch or an inch and a half or 2 inches and prints another layer on top, and then another layer on top, and another layer on top. And by the time you get 100 layers, you have the shell of a house. And that typically takes 24 to 48 hours, and you have a full double-walled house ready to be closed in and finished. There's more to it, and there's more than one way to build a printer, but that's the basic technology in a nutshell.
Wow. Fascinating. So thank you for that explanation. So concrete, you said, right?
I did.
Okay. Very good.
Here comes the zinger.
The zinger? What do you think I was going to ask?
Oh, I thought you were going to tell me that concrete is horribly environmentally unfriendly and that we shouldn't use it.
Okay.
Because of its CO2 content.
Okay. Well, just elaborate. I was not going to ask that, but that sounds interesting.
Okay. Well, one of the concrete is basically 4 components: sand, gravel, water, and cement. And the conventional concrete that we're all familiar with, the cement is Portland cement, pardon me. And that's made by first dynamiting a mountain, collecting all the limestone from the mountain, cooking it at thousands of degrees, burning usually natural gas in order to get it that hot. That process drives CO2 out of the limestone into the atmosphere, leaving you with Portland cement. It's pretty nasty. If the Portland cement industry was a country all on its own, it would be the 3rd worst CO2 emitter fourth after China, India, and the United States.
Goodness.
It's nasty, nasty stuff. But the good thing is there have been alternate chemistries since long before Portland cement got invented. The Romans built out of concrete, and some of their stuff is still around 2,000 years ago. They used volcanic ash instead of Portland cement. There are at least a dozen alternate chemistries, and we have access to one of them that doesn't use Portland cement and therefore is literally more environmentally friendly than stick-built construction.
Wow. So elaborate on that part then. How is it more environmentally friendly than stick-built? And how does it, some of the other concepts of green and sustainability we talk about, like energy efficiency and so forth, how does it fare under, in those considerations?
Well, our chemistry is, the cement is 80% less carbon intensive than Portland cement, leaving a finished concrete that's 50 to 60% less carbon intensive than conventional concrete. Consider that our houses will last anywhere from 3 to 10 times as long as a stick-built house. All the carbon that goes into a stick-built house gets repeated every 30 or 40 years as that house is torn down and rebuilt and torn down and rebuilt. I have read 2 different studies on the waste produced by home construction. One says that 10% of all the building material taken to a building site is hauled away to the landfill at the end of the job. And another one says that up to 7 tons of waste is hauled away from the construction of a single family home. With the construction 3D printing, we bring the dry powders on site, add water, mix it on site in a very small mixer about the size of a washing machine, pump it out, place it exactly where it's needed, and then when the build is done, we flush the hoses and nozzles, creating 1 or 2 5-gallon pails of waste for the entire vertical construction job. The cost savings by not having to haul this stuff, not having to hire a laborer to pack it out to the dumpster and then having to pay to have it hauled and dumped is significant. But the environmental saving there is very, very real.
So for those of us more accustomed to that stick-built construction in hearing the explanation of the rope analogy of, layer by layer going up into the building up the structure of the house, going through our head is the list of all the things that are traditionally inside those walls, like wiring and ductwork and insulation and plumbing. How is that then all accounted for and planned for under this model?
Well, we all know that concrete on its own is not a particularly good insulator, right? You get about R1 per inch. So all construction 3D printed buildings are built with a double wall. Earlier stages, earlier constructions, if you imagine a piece of corrugated concrete on edge, you look at it, you've got a flat inner, a flat outer, and a corrugated piece in between. That makes it insanely strong, much, much stronger than the paper it's built out of, and it gives it some substance. So what we do is we print the inner wall, the outer wall, and a sine wave between them, creating a significant gap. We can adjust that gap wider or smaller or narrower to suit where we're building and what the requirements are. We can then fill those gaps with loose fill insulation of, whether cellulose or rock wool or any of a dozen other things. If we were building in the very high north where they see 50, 60 below zero, we could use self-expanding foam. We wouldn't normally choose that because it's not so environmentally friendly, typically. So anywhere below the Arctic Circle, we'd want to stick with conventional loose fill insulations. Because the walls are hollow, things like wiring and such can be dropped down inside from the ceiling space, and then it's a simple matter to cut a hole, and you can do that when the concrete is soft, or you can wait and use an oscillating cutter and cut them in after the fact. There's also an option to place plastic wireways and pipe chases. Let's say you want all your outlets at 15 inches. When the machine gets to its 15-inch mark, you lay plastic pipe down, fit all your boxes and stuff, print over it, and then electricians and plumbers can pull their their services through those plastic wireways. And we might use those for interior walls, for instance. Coming down from the top seems to make more sense for the anything that needs to be on the exterior walls.
So I noticed that you talk a lot about the need for affordable housing and seeing 3D printing as a way to meet that challenge. Tell me a little bit more about what you see, as the need for affordable housing, and any rough idea how the numbers stack up with 3D versus traditional stick built.
Yeah, absolutely. This is near and dear to our hearts at 3D PHC. Now, make no mistake, we intend to be profitable, and with any kind of luck, we'll make quite a lot of money. But we are dead-eye focused on, first off, affordable housing, which is defined, at least in Canada, as housing for which the cost to live is subsidized by some level of government or a nonprofit organization. And there is not enough of it in Canada or in the United States. If we move outside what we can maybe call social housing, then our focus is on housing affordability. And even though it's almost the same two words, that's a slightly different concept. That's the relationship between the retail price of accommodation, whether to buy or rent, compared to the median income in that jurisdiction. So some numbers and I'll work in percentages as much as I can. Canada has about 1/10 the population of the United States, 38 million versus 350 million, but we'll call it 10% just because it's easy. So about 20% of the population in both countries is considered house poor. That means that more than 30% of a family's take-home pay is dedicated to shelter, mortgage, rent, and utilities. In Canada, that's about 7 million people. And in the US, that's, are you ready for it? 70 million people. When shelter takes up more than 30% of your income, there's not enough left over for other necessities and even less for niceties. Life is much harder than it should be in two of the wealthiest countries on the planet. I'm sure it's the same in the US as it is in Canada. The plight of the homeless is in the news every day, whether it's homeless veterans or just homeless in general. And they're up to levels not seen since the dirty 30s. How we got there has two answers. One's a pretty short answer and one's relatively long and much more complicated. The short answer is that demand simply outstrips supply. That's the standard capitalism answer to why is housing so expensive. When demand outstrips supply, that pushes prices up. That shuts people out of the buyer's market and pushes them into the rental market. That causes upward pressure on rent, which pushes more people into the social housing market. That is chronically underfunded, resulting in increased homelessness. Well, that's the super short, don't want to learn version of how we got there. We're now seeing families with both parents working that are living in cars and vans with their kids. It's absolutely unconscionable. For the longer answer, we need to look at how the concept of home has changed. Prior to World War II, home was where you settled down and raised a family. The house was often passed down from several generations. Roots were deep, and the house became your home, where family gathered. If the house did change hands, it was often sold to a family member, and a single lawyer would handle both sides of the transaction. As the post-war economic recovery took hold, this started to change, partly due to migration to cities, partly due to inflation, and partly due to advertising and marketing by some really influential groups. It was now possible to hold a house for a few years and then sell it at a profit that could never be had by conventional investment means. Nowadays, houses change hands on average every 4 years. This is so different from the generational holding of a home before. Each transaction has to cover the cost of 2 lawyers, one or two realtors, and a handsome profit for the seller. Even with no other forces at work, house prices are forced to rise way faster than wages or inflation. But there are other forces at work. There's now a large and lucrative industry built up around the concept of house flipping. Buy the least expensive house on a block, spend a few dollars on cosmetic upgrades typically, then sell the house in a few months, or better yet, a few weeks, and pocket a handsome profit. Thousands of millionaires have been created by inflating the cost of basic housing. Effective marketing campaigns have changed the tone of the old proverb, "A man's home is his castle." It used to mean that home was your sanctuary, a place of refuge from the outside world. Now it means this is how I show off my success. I live in a castle. In recent decades, houses have grown from 700 to 900 square feet to 1,600 to 2,200 square feet and more. Many homes have rooms, much like in a real castle, that sit empty year-round. We seem to be stuck on a bigger and bigger is better treadmill, and it's costing us dearly. North American banks and financial institutions are, deliberately or not, supporting and feeding this paradigm shift. Every banking website in Canada and the US, and I challenge you to go look at your banking website, has a mortgage calculator online. Every one of those useful tools carries a heading, something like, "Let's see how much house you can afford." And they provide helpful hints and tips as to how to borrow more money to buy a more expensive house. Exactly none of these sites asks, "Let's see how much house you need." Bigger loans mean bigger profits. 3D PHC always leads with how much house do you need, then we design to that.
Totally different perspective. Absolutely.
It is.
So how else do you see 3D printing then addressing that multi-generational kind of trend at this point?
Well, one of our focuses at 3D PHC is the concept of, we call them backyard suites where I live. They call them granny shacks out in Ontario. They call them laneway suites in Vancouver. I don't know what they're called where you live. But for a remarkably small amount of money, we can build a fully functional 1 or even 2-bedroom house in your backyard. And this allows, if the parents are, shall we call it, middle-aged, somewhat younger than me, their kids can move out into that while they save for their own house. If the generations are a little older, up closer to my age, then the parents can move into that, let the kids have the big house, and the grandkids get to spend time with their grandparents because they're right in the backyard. Multi-generational or intergenerational living becomes a real option at a very reasonable cost. So that's one thing we can do. The other thing is, because of some of the things I've mentioned earlier, a 3D printed house can, if well designed, cost 30 to 50% less than a stick-built house. If we maintain our profit margins at the industry standard, we can still make good money and sell houses hundreds of thousands of dollars less than conventional stick builders. This is good for society all around.
Sure. How are building codes catching up with the idea of 3D printed homes? I mean, that has to be a issue, I'm sure.
Yeah, that's almost the first question we get asked by people in the know. So first off, we've been building with concrete for 100 years, more or less.
True.
And we're building with concrete. Second, we've been building with CMU or cinder block for 60 to 70 years. And if you think about my corrugated cardboard analogy, this is really concrete blocks without the mortar joints. So as there are no building codes anywhere in North America that deal with 3D printing as a technology. There is an international ISO ASTM group that is writing worldwide standards, and I sit on that committee, and another of our directors sits on that committee. So we're helping write the standards internationally, but it will take years for those to filter down to the local level. Every building code that I've ever read, and it's more than a couple, has a section that deals with alternate methods or materials. And it basically says, if you can prove to us with engineering reports that your method or your material is as good as or better than section above, then you're allowed to use it. Well, we have to be stronger and better than a 2x6 wall. It's concrete, for God's sake. We are stronger than a 2x6 wall. So if you combine all of those factors, we can and will get buildings permitted. It's been done so that there is now one 3D printed house being lived in the Netherlands. There is one being lived in Germany. There are about 10 or 12 really small ones in Mexico. They were built by a U.S. company as part of a slum remediation project. Bully for them. A shout out to Icon Industries. There are 20 or so under construction in the U.S. There's one in Virginia, a couple in New York, and a couple in California, I think. The industry is truly as new as you think it is. I think we're past the bleeding edge, but we're still on the leading edge of this wave to come. We at 3D-PHC, we're actually writing a webinar to teach the planning application people, planning permit people, the building permit people, and the building inspectors what to look for, what to expect. And we'll actually make that available to other companies who want to build so that they can train the people in their locale. The funny thing about this, I guess it's funny, is we welcome dozens or hundreds of companies to join this revolution. The need is so great and the demand is so great that we should not be competing with each other for market share. We should be competing with homelessness and housing affordability to fix this mess. There's one UN study that says between now and 2050, humanity will have to build as many homes as it has in the previous 2,000 years.
Wow.
The demand is outrageous. You look at a country like Canada, we have 35 million people, and our government has set an immigration target of 400,000 people a year. We don't have enough houses for the people who live here now, and we're going to bring 400,000 a year more in. The demand is never ending. So let's get on it.
Absolutely. So Canada was not on your list of countries there, I noticed. So how far off is Canada from having a 3D printed house thanks to 3D-PC?
We have one manufacturer of printers in Canada. They're in a small town called Nelson in British Columbia, about 7 hours west of me. They built a demonstration house to show off how capable their printers are. It's called the Fibonacci house because it's got an ever decreasing radius based on the Fibonacci sequence. It's like the inside of a snail shell. I think it's about 235 square feet. They built it in their back lot, and so it couldn't be permitted because it wasn't zoned residential. They dismantled it. It was printed in pieces. They dismantled it, moved the pieces out to a recreation lot on a lake nearby, and it's now permitted. And it is, to this day, the only 3D printed house available on Airbnb. I don't know if it's been rented yet, but it's available there if you're interested. So there are no houses being lived in Canada, exactly zero. There are a couple under construction, 2,500 miles east of me in Ontario, And we are aware of 2 social housing projects that hope to use 3D printing to build them in the building season of 2022. It's new.
Yeah.
So where does 3D PHC fit in all of this? I was going to ask if you were going to be building the printers. It doesn't sound like it. So you would be more a builder. Is that correct? Or
That's correct. We will buy 1 or 10 or 100 printers and scatter them across the country, and we will build homes. We have
Awesome.
no particular interest in building printers. Other people have spent 5 years of their lives building, designing, working the kinks out of good printers. We're not up for that.
So on a typical job site where a 3D home or a printed home is being built, how many workers are there on that job site? I would have to think it's minuscule compared to a normal stick-built home.
We would have 1 printer operator or robot driver, depending on what you want to call them. Mm-hmm. 1 motorman, mudman, someone at the mixer controlling the input of the 4 components, and 2, maybe 3 people walking around checking that things are in tolerance, that the machine is not missing its target. They may also be laying those wireways and pipe chases that we talked about earlier. So the total construction crew for framing would be 5.
Wow.
And they'd be done in 24 to 48 hours. The finished walls, the printed walls, they have a texture to them. And depending on your printer and various additives, the degree to which it's textured is variable or adjustable. We've been running a poll on our website for about 10 months now asking, do you like it? Can you live with it? I don't like it, but I could live with it, or I hate it. And we're coming up with about 70% of people either love it or can live with it if it costs a lot of money to fix. So on the inside, we don't need vapor barrier, drywall, taping, and sanding. We probably want paint. On the exterior, we don't need plywood sheeting, Tyvek wrap, vinyl siding. Well, you probably want to put a coat of paint on it. And depending on the climate where you are, it might want to be special paint if we need to keep out wind and horrible, tsunami-style rainstorms and things like that.
So what does the roof look like? I have to ask.
Well, I would have been disappointed if you hadn't asked. The roof looks like any old roof you want. We typically don't print the roof. I have seen, so there's 2 ways that you could print a roof given the current state of technology. One is to print an igloo shape where you print some vertical walls and then you start making it smaller and smaller and smaller and smaller and smaller until you have just a skylight left at the top. I've seen animations of that, and I think it's been done for some very small outbuildings in Italy, I believe. So that's one way to do it if you want to have a truly 3D printed house from bottom to top. The U.S. Army Corps of Engineers, working with Caterpillar, built a printer for use in combat zones. And they printed some structures on a test basis for deployment for the military. And what they did was they built the basic structure with one wall much higher than the other and sawtoothed. And then they printed on the ground, they printed on edge, long flat panels, and then hoisted them up by crane and laid them in almost like super large oversized shingles. We're not really there yet for general use for the industry. It will come, I'm sure, because there are hundreds of people at universities working on ways to make this better. So we're going to be building conventional roofs. And that leaves lots of room for metal roofing or conventional asphalt shingles if that's what somebody really wants.
Mm-hmm. Sure. No, that kind of makes sense. And I was kind of envisioning that possibility of, pouring sort of flat panels but making flat panels on the ground and then craning them up into place. That seemed like a natural way to go as well. So good stuff.
It does. Yeah. It adds a little bit to the cost, I think.
So what other experimentation or trials are being done by those builders out there using 3D printing now? The trial and error process, what is that looking like right now?
Well, at universities all around the world and at pretty much every printer manufacturer, there are R&D projects going on looking to improve the flow characteristics, the compressive strength, the carbon footprint of the mixture. We have a group here in Calgary that's looking at incorporating hemp fiber to increase the flexural modulus, reduce the total amount of printed material, of mined printed material, and possibly sequester some carbon as well. You may know that Canada-wide, hemp products are now legal almost everywhere, and so we have a good amount of hemp fiber available. People are working with specialized accelerants that are injected at the nozzle so that you have loose, free-flowing concrete through the hoses, through the pumps and hoses, and as it gets to the nozzle, just before it's placed, there are specialized accelerants put in place so that the layer hardens quickly enough, doesn't cure, but it hardens quickly enough to support the weight of subsequent layers. This is particularly important in small homes where the nozzle gets back to the starting point fairly quickly. People are working with adding ground glass, volcanic ash. There's a research project at a university in central Canada that's looking at making the entire printable material out of recycled plastic from the waste stream, from the recycling stream. So there's, I would say hundreds of millions of dollars being spent on R&D projects to support this upcoming industry.
I'm kind of curious. So as you have seen 3D housing or printed housing developing, any real surprises along the way, things that people are like, gee whiz, we just ran into this and never anticipated that?
Maybe on the design side, not even there. That was expected. One of the cool things about the design options with 3D printing is that we can print curves, including full circles, just as easily and just as inexpensively as we can print flat walls. Anyone in the construction industry who's ever been asked to build a truly curved wall out of 2x6s and sheets of plywood and sheets of drywall knows that this is an insanely expensive process.
Yes.
So much so that people don't do it. So what we end up with conventional construction is we end up with a large rectangular box, and inside that we put flat walls to divide it up into smaller rectangular boxes. And if there's enough of these smaller rectangular boxes, then we need a long, narrow rectangular box called a hallway, which is counted as part of the living space, but it isn't because nobody lives in it. By using the advantages of being able to print in curves and odd shapes, we can design a full 2-bedroom house or 3-bedroom house with no hallways. Give it some curved walls, give it some shape, give it some interest. And there's another interesting fact about the way human brains and eyes work. When you stand inside a house with flat walls, as you scan left to right, you see the wall fade away from you in both directions. And we're very much used to that. When you put someone in front of a curved wall, if you do it right, the wall stays the same distance away from their eyes as they look left and right. The end result is the room seems bigger. the horizon is pushed out by this curved space. So you can make a 200 square foot living room look like a 250 or maybe even 300 square foot living room simply by curving the exterior wall. We can build houses that feel bigger but are smaller. And even with this technology, every square foot you build costs a little bit. So if we can give people comfortable houses that are factually smaller but functionally just as comfortable to live in, why wouldn't anybody take advantage of that?
Is it appropriate for all climates, or are there any other restrictions that, based upon location or geography?
With proper engineering, it is absolutely appropriate for all climates. As I've already noted, we can make the walls thicker with a thicker insulation space for very cold or extremely hot climates. The fact that it's a large lump of concrete gives it a very large thermal mass compared to conventional homes. This means that 3D printed houses are already partway towards a passive house or net zero certification, and the necessary upgrades are much reduced over conventional stick-built houses. If we put the appropriate exterior coating on the outside, then it can be wind and bug and mold resistant at least as well, and no doubt noticeably better than stick-built houses with plywood and that sort of thing. Concrete doesn't rot the same way. You'd probably want that coating if you're going into a very, very cold climate where water could get into the microstructure of the exterior concrete, then freeze and cause spalling. But, we do concrete bridges all the time, and they last for a very long time if they're properly maintained. Because it's a concrete house on a concrete foundation, it's inherently hurricane and tornado resistant, depending, of course, on what you put on it for a roof. But there are ways to engineer that. It's inherently fire resistant, bordering on fireproof, depending on what you use for cabinetry and that sort of thing. There aren't a lot of downsides to this.
No, it doesn't sound like it. This is fascinating. Thanks so much for all your sharing, and very much on the leading edge, like you said, of this technology and its implementation across the industry. Would love to now hear about, where do you see this going, looking in the crystal ball 20 to 30 years from now? What's the trajectory? Who do you see getting involved? Is this going to be a whole new segment, or are traditional builders going to start incorporating this technology? All those dynamics. How do you see it coming?
Well, there's a lot going on. You guys are in the construction industry, and you know that there is a serious shortage of skilled labor. And it seems to be worst at the front end. Cribbers and framers are in terribly short supply. And without those people, you can't start a house. And if you can't start it, you can't finish it. So, and this is partly because old guys like us who are leaving the industry are not being replaced by young people. They're not so much interested in what I'm going to call the heavy labor portion of the construction industry. We still have lots of plumbers and heater and HVAC specialists and electricians, but the front end is seriously lacking. So we're going to plug that gap by using a machine and young tech-savvy computer programmers, game players, who don't need to be big. They don't need to wear insulated suits to work outside. They can sit in a trailer, use drones or cameras, and they can drive the robot from inside. This means that 95-pound women or people in wheelchairs can now be construction workers. So it might seem to some that we're taking jobs from the framers, but in fact, we're adding more people to the labor pool to solve a chronic labor shortage that's likely to get worse.
Love that.
So far, I'm not aware of any conventional builders who are using this technology. And I don't see any reason that they should. House prices are high, margins are good, demand is beyond their capacity to fill. So they don't need to innovate yet. Once this gets going, once construction 3D printing becomes more normal, I think they'll be forced to either hire companies like us to build the shell and then they'll bring in their own crews for finishing, or they'll buy their own printers and do it themselves. I don't think there's any doubt that this will happen. Where's it going in 10, 20, 30 years? Considering this technology didn't even exist 10 years ago, that's a pretty risky thing to try and guess. So far, there's one 2-story house being lived in and no 3-story. There's one 2-story office building in Dubai. There's no 3-story. So that there are limitations currently based on just the way the machines work. To try and build a 5-story gantry mounted on 4 corners, hold it steady so that it can be repeatable to 1 millimeter, that kind of stuff. It'll happen, but it's not here yet. Some really smart people are going to apply AI and sensors, and if the gantry moves 5 millimeters out of place, all this machine vision and AI will just simply move the head back to where it needs to be. The other option, much like the roofing, is to print either off-site or simply on a pad next to your construction site, print a vertical wall panel, then hoist it up by conventional cranes. And with that technology, there's no reason we can't go 10, 20, 30, 40, 50 stories. There will be lots of advancements in this particular industry. At the same time, we're seeing enormous advances in modular housing, whether that's build a whole house and transport it, build a flat pack like an IKEA house, take it out to the site and unfold it. I've actually seen that one. It's neat. Build panels, load them on a truck, maybe even take 2 or 3 houses out to a neighborhood and offload them and stand them up. All of those technology, CCAN houses, all of that stuff is going to get better and smarter, hopefully more cost effective, and maybe address some of this housing shortage. As to what's coming after 3D printing, I can't guess. I don't know.
This may be a loaded question, but I'm curious, what is the upfront expense for a printer?
Oh no, that's an incredibly fair question. Printers can be had for as little as $300,000 and as much as $1.5 million and more. And that's an interesting thing because like our little company, our little startup company, we're stuck in this traditional high school graduate situation where they can't have a job unless they have experience. They can't get experience without a job. We can't raise the money for a printer until we have a project to build. We can't get a project to build until we can demonstrate a house. And so we're stuck in that same sort of loop. Now we do have a project. It's a tiny home. It's a backyard suite in Edmonton, 200 miles north of us, for spring of 22. So that's a start, but it's nowhere near enough to finance a printer. So we're still working with local authorities, local social housing providers, trying to find one that's willing to stick their neck out a little bit, I guess, and say, yeah, it's being done in other places. We can do it here.
That sounds like quite the challenge, but an exciting one to be a part of. And we look forward to staying in touch. And I get to Alberta every so often. So, it'd be fun to visit that project here.
Cool.
In the spring. So
look forward to seeing you.
Thinking about that trajectory, and you kind of referenced it, younger folks coming into the industry are few and far between, at least compared to those exiting on the end of their careers. What would you tell someone looking to get into construction or 3D printing, home construction specifically? What's some advice you would give them?
Well, I would note first that the construction industry may be the last major economic sector to take advantage of automation. Other sectors, other manufacturing sectors, have adopted automation and have seen productivity gains of 25, 50, 500% over the last 70 years or so. The construction industry has actually seen a very small decline in productivity, that is, work produced per man hour, of about 0.7%. And that's probably a combination of things like stricter HR rules, environmental concerns, workplace safety. Everybody in the industry is working as hard as they ever did, but they're not quite producing as much as they used to. So we have a situation where automation will come to the construction industry, and we're probably just the first wave. So if you have the option, learn programming, learn robotics, learn automation, learn AI, learn machine vision. All of this stuff will be applicable when you go out into the workplace, and it doesn't matter what industry you're going into unless it's retail or some of the service industries. If it involves making something bigger out of something smaller, out of smaller pieces, automation is the way to go.
Fantastic. Like I said, that's been a fascinating conversation, Ed. Thank you so much. Anything else related to, the current or future of 3D home construction that you want to touch on?
Really, just look in backyards as you wander around your city. It's coming to your city. Maybe not this year, maybe not next, but probably the year after. There will be hundreds of companies in North America that are more than happy to 3D print a house for you.
That's exciting. We look forward to working with those folks and seeing where we can move the industry forward. So before we wrap up, this has been a great conversation. Ending maybe on a little bit lighter, fun note, we want to see if you'd be willing to participate in our rapid fire question round, where with most of our guests, I think all of them at this point, no one said no to Todd yet, but answering a few, actually 7 questions. Some are a little silly, some are a little more serious, but just let us get to know you a little bit better. Is that something you'd be willing to tackle here today?
Oh, no pressure. No one's ever refused before.
Yeah.
I guess I won't break that tradition. Sure, I'll do you 7 questions. Let's go.
Very good. Thank you. So first, what is your favorite traditional Canadian food? I had maybe poutine or...
Probably poutine.
Okay, very good. Traditional toppings, or do you like something a little out of the box?
Traditional.
All right.
Gravy and cheese curd.
It's tasty. I've had it. So
it is.
Where did you go on your last vacation?
Last vacation would have been Puerto Vallarta, Mexico.
Beautiful. And a little warmer than what it is in Alberta in November.
Yeah, we always do that in the dead of winter.
Fantastic. How do you normally answer the phone?
Good afternoon, Ed speaking.
Can you describe your dream home?
A 3D printed home with main living quarters as a central pod, short corridors in at least 3 directions. One direction to a small art studio for my wife, another direction to a small woodworking studio for me, and then a third pod connected by little igloo-style tunnels, if you will, to a multi-car garage so that I could have more than one car and one motorcycle at a time.
Fantastic. Anything about the setting or the scenery?
I live 50 miles from the foothills of the Rocky Mountains. Anywhere on the edge of Calgary or slightly west would be scenically as good as it gets anywhere in the world. I would like for winters to be warmer, but it seems to me that when you trade cold winters for warm, you also trade civilized precipitation for monsoons or earthquakes or other things that I'm not used to. So I think I'll just wait for global warming to do its job and make winters a little nicer here in Calgary.
There you go. It is beautiful country, no question. So do you have any pets?
Currently, we have 2 Yorkshire Terriers.
Another small dog fan like Mr. Miller and his wife.
No, I'm a big dog fan, but they all died and we're old, so it's small dogs from here on.
I hear you. I hear you.
What is your favorite book?
I have to answer with 3 because I've read thousands, and to pick just one is not fair.
Love it.
Favorite classic, Les Miserables in the Penguin translation. Absolutely a rockin' story. Mid-century, Time Enough for Love, a science fiction piece by Robert A. Heinlein that analyzes in depth what it means to be human and specifically what it means to be a man by his standards. And for modern, Shantaram, Shantaram, by Gregory David Isles, a semi-biographical work about an Australian who escaped a maximum security prison and ended up as the medic in a Bombay slum. You've got to read that one.
Wow.
That
sounds good.
Wrote them both down, those 2. So that'll definitely be checking those out. So last one, a little more serious. What would you tell your 25-year-old self?
Go to university. When I got out of high school, it was late 60s, early 70s, 1971 actually. And it was peace, love, and brotherhood, screw the man, screw the establishment. I chose not to go to university for really dumb young man reasons and had to learn everything I learned a much harder way. I should probably have been a multi-ticketed engineer because that's the way my mind works. And I didn't do that. So I would tell me to go to university.
Powerful advice and testimony. So thank you for sharing. Well, I mentioned, asked this question earlier, but just one more time. Anything else that you'd like to have the opportunity to say or share here in our time together?
Yeah, just this morning, 3D-PHC launched its early adopter program where people can pay a small deposit, get with Frank, our designer, do some early design work on their home or their backyard suite. Check out our website at www.3dphc.ca and have a look around, see what we're doing, see what we're up to, and see how much you're interested.
Well, fantastic. Is through the website the best way for people to get in touch with you, Ed, if they so wish?
Probably. We have a contact form there. They're triaged. My personal cell phone number is actually on the website. So if people want to talk to the CEO, they can go there, and it doesn't tell you it's the CEO's number. It just gives you a phone number, but it's me.
Very good.
And I answer them all.
Well, fantastic. Thank you again, Ed, for this conversation. Learned an incredible amount and look forward to continuing this conversation as 3DPC grows and accomplishes its goals. And hopefully that leads to some opportunities for us to work together.
This has been absolutely awesome. Great questions asked by people who really want to know more. Couldn't ask for better.
Absolutely.
Well, thank you very much for your time. We appreciate it.
And those of you listening, thanks so much for tuning in to this episode of Construction Disruption with our guest, Ed Macnab of 3D Printed Homes Corporation. Please watch for future episodes of our podcast. We have more great guests on tap. And don't forget to leave a review on Apple Podcasts or YouTube if you would. Take care. God bless. This is Isaiah Industries signing off of this episode of Construction Disruption.